We're going to look at verifying trig identities. As we're working through these trig identities, what we'll be doing is simplifying or transforming trig expressions from one form to another form. This is a critical skill when it comes to solving trig equations, but also critical in terms of calculus, which many of you are heading towards. In calculus, we want to be able to apply a derivative, which finds us rates of changes, and also an integral, which helps us find things like areas and volumes. Being able to change the form of a trig function is really critical to being able to carry out those tools. We're going to talk strategy first. So as we're talking strategy, there's a couple of things to keep in mind as you're working through these, because there's so many different ways to go. One of the very first and probably most important tools is expressing everything in terms of sine and cosine. You don't have to do this every time, but it's often a really great place to start. Often we'll have fractions and fractions within fractions. So we really want to be able to find common denominators. I'm just going to abbreviate that as LCD, lowest common denominator. And we also want to clear those denominators. If you're familiar with the term complex fraction, we want to be able to clear those complex fractions. We don't want fractions inside of fractions. Another strategy, again, these don't always work, but these are wonderful places to start, is to start with a more complicated expression. If you've got more to work with, you've just got more ways of getting from one form of the expression to the other. We're going to be using some factoring techniques, factoring trinomials or factoring a difference of squares. And then we're also going to be watching for any of the identities that we have been working with so far. And I've got my trig laws and identities reference sheet here. So as we're working through these identities, we are going to be applying tangent identities, reciprocal identities. You're going to watch for those Pythagorean identities. There might even be some double angle. Certainly, where are those other ones I was looking for? Not those, maybe even some cofunction identities. So any of these identities that we have been working with are ways that we can change from one form of a function to another. Let's go ahead and start with this first example. We want to go from this original form here, sine squared secant, and we want to write it as something minus cosine. So we're going to be identifying f of x. What we're really doing is we're looking for something minus cosine x. So we want to write it in that form. I'm going to go ahead and start by changing everything into sines and cosines. So I'm going to start on the left-hand side there, and sine squared x times secant, I can write that as 1 over cosine x. I need this subtraction symbol, and right now all I have is a product. So I'm going to use my Pythagorean identity to rewrite sine squared x. For that Pythagorean identity, if I switch over here, I've got cosine squared plus sine squared is equal to 1. So I can write sine squared as 1 minus cosine squared. Let's go ahead and put that onto the worksheet in our next step. So what I've circled there becomes 1 minus cosine squared x. And I'm multiplying this by 1 over cosine x. I'm going to multiply this through, distributing. 1 times 1 over cosine, so I get 1 over cosine x, minus cosine squared x, times 1 over cosine, so I get a cosine x there. I can simplify my cosines. This is my minus cosine x, which is what I wanted for the second part. And then the first part, that's what I was solving for. That's going to be my secant x. So secant x is what goes on that blank right there. So the missing function that we were looking for, f of x, is secant x. Let's take a look at the next one. Again, I noticed that I've got secants and tangents, so I'm going to go ahead and use that first strategy of getting everything in terms of sines and cosines. So I'm going to start with that numerator. I want blue. I'm going to start with that numerator, and I'm going to write secant as 1 over cosine. And I'm going to write tangent as sine over cosine, sine x over cosine x, 1 minus sine x. What I have here is a complex fraction. I have fractions within this fraction. So I want to go to strategy number 2 here. I want to look for some common denominators and clear denominators where I can. Well, I do have a common denominator already in the numerator. So if I just kind of group this numerator here, I notice that I've got a common cosine x. I can go ahead and combine that numerator into a single fraction with cosine x as the denominator. My numerator is 1 minus sine x. All of this is still over 1 minus sine x. The next thing that I want to do is to take this division symbol right here, which is really my fraction bar, but that is a division symbol. And I want to rewrite this by reciprocating my denominator. So right now, this says 1 minus sine x over cosine x divided by my denominator, and I'm going to write that over 1. 1 minus sine x over 1. Instead of dividing, I'm going to multiply by the reciprocal. And I'm almost to my simplified form. So this becomes 1 minus sine x, I leave the first one, over cosine x, times, I'm just going to reciprocate this guy, and I get 1 over 1 minus sine x. Now I can simplify by canceling. I get 1 over cosine. Simplified all the way down to a single function is secant. All the answers won't be secant, I promise. So this is equal to, I'm just going to write it right there, secant x. So now I've got it simplified into a single function. Okay, number 3. I also want to simplify this into a single trig function. And I'm going to put everything in terms of sines and cosines. So that cotangent is cosine over sine. In my denominator, I've got cosecant, which is 1 over sine, minus sine. Are those all t's? And I just changed them all to x's. That's okay. I do want to go ahead and get a common denominator. So I'm going to work in the denominator. I've got this complex fraction, and I'm going to build a common denominator, which is just, my LCD is sine x. So the first fraction in the denominator has sine x as a denominator, but the second one doesn't. So I'm going to multiply this by a sine x over sine x. Leaving my numerator for now, cosine x over sine x, all over 1 over sine x minus sine squared x over sine x. That numerator is cosine x over sine x, all over. I can go ahead and take that denominator now and combine it into a single fraction, all over sine. So I get 1 minus sine squared x divided by sine x. Now we've done this before. This original fraction bar really is a division symbol. I'm dividing by that denominator, but instead I'm going to write it as multiplying by the reciprocal. So in my next step, I'm going to write this as my numerator. Let me put a line here so I don't get this mixed up. Cosine x over sine x, that's my numerator, multiplied by the reciprocal of my denominator, sine x over 1 minus sine squared x. I can cancel my signs. I end up with, hopefully you wrote smaller than I did. I'm going to write right here, but you might want to write on a separate piece of paper because I'm going to end up erasing this. I have cosine x in my numerator, 1 minus sine squared x. If I go to my trig identities, 1 minus sine squared is cosine squared. 1 minus sine squared x. So that's another form of my Pythagorean identity. So I can write that denominator as cosine squared x, and I get 1 over cosine x. And guess what? I get secant again. Like I said, they're not all going to be secant. I already said that, didn't I? Okay, secant x. secant x, secant x. I promise they're not all going to be secant x. Okay, number 4. So in number 4, I'm going to do the same thing again. Everything in terms of sines and cosines, but I really just have that very first secant that needs to be changed into sine. We're looking for, into a cosine. We're looking for this blank, something times secant squared. So I'm just going to dive in and start simplifying using my sines and cosines. So I've got 1 over cosine x minus cosine x, all divided by cosine times sine. I'm looking for a common denominator. I've got fractions in my numerator. My LCD is cosine. It's the only denominator on top there. So I'm going to multiply that second cosine by cosine over cosine. This one turns out to look a lot like the first one, really similar work. So I have 1 over cosine x minus cosine squared x over cosine x, all divided by cosine times sine. Combining that numerator into a single fraction, I get 1 minus cosine squared x over cosine x, all divided by cosine sine. You might be ahead of me noticing that this numerator is the same as a sine squared x. So I'm going to go ahead and replace that. This is my division bar right here. So there's my division. I'm going to think of that denominator as cosine sine over 1. So I'm going to multiply by the reciprocal. So I've got sine squared x over cosine squared, and I'm going to multiply that by the reciprocal of my denominator. Okay, so moving down to the last line here, I have sine squared x over cosine x times the reciprocal of the denominator, so it's 1 over now, cosine x sine x. I can cancel a single sine, so I end up with sine x over 2 cosines. And I could write that as cosine squared, but I'm thinking ahead. I wanted to write this as something times secant squared. So I'm going to just separate this out, and I end up with sine x times 1 over cosine squared, which is sine x times secant x. Just enough room. So f of x, I'm going to write this in green, is sine. See, I promised they wouldn't all be secants. Okay, so f of x, that missing blank, it's something times secant. Something times secant squared. And that blank then is sine. Okay, so you might want to give yourself more room than I've given myself here when you're doing your own work. Part C. So now instead of simplifying expressions, we are verifying identities. We want to show that the left-hand side is equivalent to the right-hand side. We want to make sure and not combine these. We're going to continue to use the same strategies that we have up above, starting with sines and cosines. So I'm going to go ahead and start on the left. So on the left, we've got tan squared, and I'm going to write this in terms of sines and cosines. So sine squared over cosine squared minus sine squared. I'm going to continue to work on the left. I'm not going to say equals this because I haven't shown that yet. So I cannot assume that it's equal until I've shown that. As I'm working with one just by itself, I notice that I need to go from a subtraction to a multiplication. So that means that I want to combine this into a single expression. We're going to use common denominators. My common denominator, my LCD, is cosine squared. So I'm going to multiply this by cosine squared over cosine squared. This gives me sine squared x over cosine squared. Actually, let's write this all as one big fraction. It's going to make my life just a little bit easier. So the entire numerator then is the sine squared x minus sine squared x cosine squared x, all divided by cosine squared x. I'm going to factor. I've got a GCF in my numerator, and that is my sine. So I'm going to go ahead and factor the sine squared x out in front. I'm still working on that left-hand side, but I'm keeping my eye on the prize here. So I'm going to factor out that sine squared x. Sine squared divided by itself is 1. That's this guy. Sine squared cosine squared divided by sine squared is minus cosine squared. All over cosine squared x. Now remember, I'm keeping my eye on the prize, which is this guy. Not the whole thing, just this guy. I do have tangent already. This right here is tangent. So I need this guy to be sine squared. And it is. My Pythagorean identity tells me that it is. So in my next step, I'm going to simplify so I can get the form I was aiming towards. Sine squared over cosine squared is tangent squared. And my 1 minus cosine squared is sine squared x. So that verifies the identity. Number 2. So in number 2, I can start either on the left or on the right. I like to start with a more complicated side because it just gives me more to work with. But you don't always start with the left-hand side. A lot of the times you do. That's just because of the way the math world tends to think. One of the things I love about the math world, but I'm definitely going to start on the left here. I cannot assume it's equal to the right now. So on the left, I'm going to write everything in terms of sines and cosines. So probably my most used strategy up to this point. Okay, 1 over cosine x, and cosecant is 1 over sine x. I've got a complex fraction, so I've got fractions in this denominator. My LCD needs to include both denominators. So I need the cosine and the sine. So I need to multiply the first guy by sine over sine, and the second guy by cosine over cosine. So we get sine x plus cosine x in the numerator. In the denominator, what's circled there, I do have a common denominator of sine cosine, so I can combine everybody. The order of these two don't matter. Multiplication's commutative, so either order with the sine and the cosine there. Up on top, I have sine plus cosine. Sine x plus cosine x. I want to combine this using my fraction bar, which is division. So really, I'm going to multiply by the reciprocal of that denominator. Lots of common themes here. This gives us sine x plus cosine x. You can think of this as being over 1, that's my numerator, times, that's where the division was, and I'm going to reciprocate that denominator. So sine x cosine x, do you see I'm almost there, divided by sine x plus cosine x. Now these match perfectly, and we get sine x cosine x. If you happen to write it in the other order, no big deal, you can swap that. But we were able to show that we can go from the left side to the right-hand side. Okay, one more, number 3. So in this one, this is a double angle formula for cosecant. We don't have a double angle formula for cosecant. That's a mouthful because we don't really need one. Now, in this case, this is the more complicated version. You could certainly use this side if you wanted to, or you can use the left-hand side. It doesn't matter. I'm going to go ahead and do it on the right. So on the right, I'm going to write things in terms of sines and cosines. So I have 1 over 2, 1 over sine, 1 over cosine, which is 1 over 2 sine x cosine x. That should feel familiar. It is one of our double angle formulas. If I go over to our reference sheet and to our double angle formulas, that denominator is the sine of 2 theta. So I can replace the denominator with the sine of 2. I think we had x here. So this is equal to 1 over sine of 2x, but I've got the reciprocal of sine, and that is equal to cosecant of 2x. So we have verified that identity. This time I went from the right side over to the left-hand side. So there's several different strategies. If you take a look at our strategy list up above here, we have used all 5 of the strategies here. I would say that the strategy, putting everything in terms of sines and cosines, is probably the most important of our strategies. We did work on LCDs and working with denominators quite a bit. We looked on starting with the more complicated side of the expression when we had 2 expressions that were equal. We factored out a common GCF, and we really did watch for those identities from our identities reference sheet.